Here is a little introduction to tessellations. So basically a tessellation is just a term in geometry that is used to describe a pattern that covers a surface that doesn't have any gaps or overlaps. So it's when the shapes come together perfectly and they fit together perfectly without any spaces or gaps. And there are many tessellations in nature, and there's some examples like the honeycomb is a great one, a pineapple, pine cones, all of those things are tessellations. And then art and architecture have a ton of tessellations as well, and there's actually some really famous artists who have basically made a name for themselves by doing artwork that is based on tessellations. So the first thing that I want you to do is click on this link, this polypad link, and create your own tessellation. So you're going to spend a few minutes just playing around. You're going to drop regular polygons. So be careful. Remember, a regular polygon is a polygon where all the sides and angles are equal. You're going to find the polygons and shapes section on the polypad, and you're just going to kind of play around with it. You're going to use one type or a combination and see which of these 6 regular polygons will tessellate and which ones will not. And in your slideshow, all you're going to do is screenshot maybe 1 or 2 of the tessellations that you created. So pause the video and give that a try, and then you can restart the video once you've had a chance to play around with that. So now what I want you to think about is, based on what you did when you were playing there, which polygons did tessellate? So did an equilateral triangle tessellate? Did a regular pentagon tessellate? Did a regular hexagon tessellate? What about some of the other shapes? What if you combined 2 shapes together? Did those tessellate? So just take a moment to kind of reflect on which shapes did tessellate, meaning which shapes were you able to put together without any spaces or gaps, and which ones were problematic for you. And then I want you to, again, just be able to think about this, because I'm not in class. We won't be able to have a discussion about which shapes did combine well and which shapes did not. Were there any regular polygons that we used that did not tessellate with each other? And is there anything that we can do mathematically to predict whether or not a polygon will be able to tessellate? So I want you to think about that. In the second question, I want you to think about, in terms of the ones that did not tessellate, if you only used one shape. So for example, if you just used a triangle, did just triangles tessellate? Or if you just used a pentagon? Sometimes they will tessellate with a combination of 2 or more polygons. Okay, so here, one of the things hopefully that you're starting to see is that shapes will tessellate based on their interior angles. So when we join shapes together, the vertices need to meet up at a point, and the distance or the angle around that point, not the distance, but the angle around that point always has to equal 360. So these are some examples where shapes, again, meet at a particular point. So right here, these shapes all meet right there, right here, and right here. And for you to be able to tessellate, the angles at that point need to add up to 360 degrees. So the interior angles have to add to 360. So you're going to see in this example, that does not happen. Now, you might be able to tessellate if you use another shape to make up the difference of the angles. But that's a really important thing to notice about tessellations. And then, as I said, sometimes you can tessellate with a combination of polygons. These that meet at a point will all add up to exactly 360 degrees, and these are some examples. You also can tessellate irregular polygons. It can be a little bit trickier because, again, you still have to be able to add up to 360 degrees. So some triangles will work that way, and here are some other pictures. You can read about a little bit more about it. Pentagons are probably one of the trickiest shapes to be able to tessellate just because of their interior angles. And then tessellations in art. So one of the most famous artists that uses tessellations is an artist called Escher, and these are some examples of his artwork. Please Google it. There's some really, really cool pieces that he's made, all based on this idea of tessellating, also based on the idea of transformations. So we just finished transformations, and a lot of his artwork is based on translations and taking part of one shape and moving it somewhere else, or based on rotations. So to finish up the work on tessellations, you have an assignment that you need to do, where basically you have to explain to a friend that missed class how you could define a tessellation. You can use words, drawings, etc., and make sure you make mention of knowing which shapes will tessellate and which shapes will not. Hint, hint, make sure you talk about which angles they have to add up to at any given point.